I want to welcome everyone to our second Weiler Wednesday webinar, Pro Tips for Weld Blending and Finishing. I'm Nate Schmidt. I'm the Director of Marketing at Weiler Abrasives, and I've got Ron McCarthy, our abrasive specialist based out of the great state of Louisiana, on the line today. He's going to walk us through the presentation. Before we do that, for those that are joining us for the first time, the purpose of these webinars is really to provide a brief, high-impact set of content and information that you can take and deploy in your operations to make you more efficient and more productive, or if you're one of our distribution partners, that you can take to your end users to make them more efficient and more productive. Just a couple ground rules on Zoom. So we will handle questions and answers at the end of the webinar. However, you can submit those via the Q&A function at the bottom of your screen. You should say Q&A. If you click that, you can type a question in, and we'll save those for the end, and we'll take as many questions as we have at the end of the presentation. In addition, we will do a couple polls throughout the presentation. We'd encourage you to provide your feedback on the polls. Before we get into the slides for today, I did want to talk about our response to COVID-19 briefly. If you are like many of us, you are been deemed one of the essential businesses, and we continue to operate our facilities around the globe as many others do in order to service those critical infrastructure businesses that rely on our products. And I want to thank our coworkers that continue to go into our factories around the globe every day so that we can provide those products to those industries. And I also want to thank the medical professionals and healthcare professionals that are helping us to get through this crisis. To learn more about our response, you can go to our website, weilerabrasives.com, or you can follow us on our social media outlets, Facebook, Instagram, and LinkedIn. So the topic for the webinar today is, again, pro tips for weld blending and finishing. We're going to cover a couple different areas. We're going to start with surface finish basics. We'll get into how to select the right product for weld blending and finishing. And then we'll also talk about some tips and tricks you can use in the field to optimize those applications and get the most out of the product. And then lastly, we're going to highlight two of our newest products and our most innovative products around blending and finishing. And that's our Tiger BobCat mini flap disc and our Tiger X flap disc. So without further ado, I will hand it over to Ron McCarthy. Take it away, Ron.
Well, thank you, Nate. Welcome to everybody. As we begin today, let's begin by briefly discussing specific and measured metal finishes. This is a topic we will not dwell on or dive deep into, but it serves as a great counterweight to visual finishes and to weld blending, which we'll focus on. First, metal surface finishes can be specified by parameters and measured. Secondly, metal surface finishes are widely varied in what they are meant to do and are meant to achieve, and how you get there. Although we may look at, you or I, a stainless steel countertop and believe it's smooth, straight, and flat, that can be far from the truth. Only through specified parameters and measurement can metal surfaces be compatible to be used in exacting applications. For example, in the food industry, the idea is to set a parameter which will reduce bacteria growth through metal finishing. So if we highlight this steel surface graphic, you'll notice that there are waves and ridges, where the ridges are actually peaks and valleys that are measured in this chart above. Roughness average, or RA, measures the deviation between the valleys and the peaks. So back to the food service example, you want to reduce that average variation or so that it's more easily disinfected. It's also important to know that finishes that are specified always have a purpose. Blueprints will specify the method and the quality of finish. RA is the most common method of measurement in the US, but there are many more. Though we began talking about specified finishes, the most common finishing in fabrication is weld blending, and it is rarely measured. So today, we hope to provide tips for picking the best product for weld blending applications, and we'll discuss the best methods for attaining the desired results. In the time we're presented here, we can't go through all the blending possibilities. However, if you do have a specific question about a specific application, please reach out to us through Zoom, and we will reconnect with you. To begin building our product selection framework, let's start with 3 criteria we've listed on this slide. I'm sorry, my laser, there it is. So the top 2 tools are meant to go on a right angle grinder, and the bottom tools are meant in an air tool or straight die grinder. You always need to obviously match the tool to your grinder. But also about tools, think about the weld size in comparison to the tool used. If someone is welding 2 1-inch pieces of plate together, a 4.5-inch grinder would be an appropriate size tool. But if one's blending the weld on the hull of a ship, well, you'd probably want a larger tool, maybe a 7-inch. This coordination in size prevents grind lines, which would show through painted finishes or might create backup work to blend out imperfections. While we've talked about size, it's appropriate to discuss the engagement of the disc. Because just because you use a larger disc, if you don't engage the full surface area, you really overwork yourself and underwork the product. Fully engaging the surface of the disc provides for smoother and more consistent finishes because of a lower grinding angle. My good friend Rick Hopkins likes to talk about hiding a seam in drywall. He says it's easier and faster with a 12-inch drywall knife than the 4-inch knife. So consider tool size whenever possible. As we talk about coated abrasive considerations, one of the first we want to discuss is a resin fiber disc. Resin fiber discs are arguably the most aggressive coated abrasive disc available. When they contact the surface, all the abrasive is engaged with the metal. Now, it's not as durable as a flat disc, but it does have great conformability. And again, you can notice it right here. It'll bend. The need for a backing pad and the metal attachment in the center of the disc prevent full engagement, and they do limit the life of the disc. A flap disc grinds like a grinding disc, but it's a lot easier to control. Because of the coated abrasive, it leaves a better finish, and lighter pressure is needed to make it work. And lastly, it does outlast resin fiber disc. In selecting a coated abrasive product, how it cuts relates to the grain and to the grit. Grain can affect the application through performance and cost, and choosing a grain should never be done in a vacuum. Look at tooling, look at expectations, look at the finished conditions. But there are multiple grains available. Today, we're only going to discuss 3. Ceramic is a grain which has the ability to fracture at an extremely high rate. Under pressure, the ceramic grain fractures readily and it stays sharp. It aggressively removes metal. A ceramic disc can really maintain its initial cut rate for up to about 80% of the disc life. This grain is a beast in pure metal removal, and it is a go-to grain to grind hard alloys like stainless and Inconel, ballistic steels. But because of its nature and its metal removal rate, it actually may not be the best choice for blending. Its cost has to be considered, and it needs to be run on high-powered electric grinders and air tools. The zirconium alumina grain has, over many, many years, performed at a high rate. I like to say it's the utility player on the baseball team. The guy who can play shortstop or second base, hits well, and the coach rarely has a problem with him. Considering a blend of performance and cost, zirconium alumina is still the most widely used grain in coated abrasives. The last grain we'll talk about is aluminum oxide. And it's a hard grain. And typically, it's found in resin bonded abrasives or grinding disc, hard disc, and resin fiber disc. Aluminum oxide is a blocky shaped grain. And while it's initially very sharp, it dulls or rounds because it doesn't fracture easy. But think about finishing, that can work for you. And so this grain lends itself pretty well to weld blending. In selecting grit, it starts with you determining how aggressive you want to be and what scratch patterns would be acceptable on the finished part. Lower grits like 36 and 40 remove metal at a substantially faster rate than, say, a 60 or an 80. Yet they do leave a more pronounced scratch pattern, which, depending on the goal of the application, could require multiple steps or extra blending at the end. As we look at the styles of the disc, we're going to talk about all 4, but we're really highlighting the Type 27 and the HD 27 disc for blending. The Type 29 is a conical styled disc, and the angle is pressed into the flaps. And it allows surface contact up to about 35 degrees. If it's used to grind flat surfaces, really good pressure control may be required to prevent unevenness. Our Type 27 has a flat grinding profile, which requires a much lower angle of attack. It's easier to control unevenness. Our angled disc It's really kind of a unique disc. It has a 90-degree flap design which wraps up the edge of the backing plate. And this disc really excels at blending perpendicular or angled welds like T-joints and lap joints, which are commonly referred to as fillet welds. The HD, or high density style, combines or can combine the flat grinding profile of type 27 with an increased amount of abrasive cloth. They're thicker and more ergonomically styled with some cush or give under slight pressure, and this makes it a great candidate for blending welds.
All right, thanks, Ron. Before we move into the tips and tricks, just a quick giveaway. So we have a question here on the screen. We're going to give away a Weiler power pack for your mobile device. And the first person to answer in the chat box in Zoom, the correct answer will win this power pack. So the question is, name the most common non-measured finishing done in fabrication. And we'll announce the winner at the end of the presentation. Go ahead, Ron.
We have discussed, sorry about that, guys. We've discussed some thoughts centered around the product selection, but how the product is used is as important as the tool. So if we look at the angle of approach, you can see how the disc is much flatter and how this is much higher. The flatter disc allows for full engagement of the flaps. It allows for an easier stroke and lighter stroke. If you compare these two, you can see that this would require more pressure, which is going to cause an unevenness. If you look here on the disc, worn disc shown, you can see what happens when you grind up on the edge. You end up wasting a lot of abrasive cloth and wearing the disc out quickly. We have a couple of videos that we're going to quickly run through that will show you some different styles of grinding. One's a choppy stroke that displays short, jagged movements. And when you watch it, notice he starts grinding forward. He dwells too long in some places. He exerts too much pressure, and he's generating a ton of heat, which is going to kill the abrasive life. This style is also going to accentuate the scratch pattern, which we're going to see on the next slide. The second video that's starting, you notice he started with a backwards movement. And he's demonstrating very long, consistent strokes that we just call smooth. It's the Beethoven of sparks, if you will. Notice he's got a flatter grinding angle, and he's not dwelling. So this is the metal of the short choppy. You can see it has marks where he's dwelled too long. You can see the lines. It is not a clean grinding. Yet if you look at the metal where he took the long, smooth, consistent strokes, you have reduced heat discoloration. You see it's a much more even and consistent finish. Now this is our Tiger X flap disc. There is no such thing as a one-size-fits-all abrasive, but in weld blending, you are often forced to make a decision around selecting a more aggressive disc that will remove weld material quickly, but leave a scratch pattern, or choosing the finer grit for blending, which at least feels like it takes forever. Tiger X gives you both, and it separates itself from any other flap disc on the market. First of all, the top flap is aggressive. It's a mix of zirc and ceramic grain. The bottom flap is tailored to blending and allows you to lighten pressure and go into a blending stroke to achieve the visual finish you expect without having to change disc. Now, there are many discs on the market that have two flaps, but these are paired. These are paired. So they're meant to accomplish what they're at. We call it an X3 technology. It has all three grains in the flap disc. We'll talk a little bit about BobCats because, again, one of the problems often with weld blending is getting into tight spaces. So the BobCat gives you all the advantages a flap disc give you over a resin fiber disc. That's the life. That's a type 29 or type 27. And we make it so that it is currently available with an S mount and an R mount. In summary, make sure the application fits the power tool. Match the tool size to the application. Know the expectations and plan how you want to get there. Know the conditions of the application, the type of metal, and the shape. Blending is made easier by ensuring the maximum number of knives or contact in the work. That means the surface is fully engaged. That allows for smooth strokes, for heat dissipation, and by spreading the contact patch as wide as humanly possible, it allows you the better finish. Remember the drywall analogy. Use lower grinding angles, reduce pressure, and don't be choppy. Practice smooth and consistent strokes. And with that, we're going to complete our webinar.